Hi, my name is Larissa. How are you doing? We're constantly trying to ask questions and find answers to them. Some are easy to answer, like, how are you? But others are more difficult, and we would have to conduct an experiment to find the answer. But when we conduct experiments, we need a way to interpret our data to form conclusions. We use a method in statistics called significance testing. And this is what researchers do to draw practical conclusions from numerical data. We start with a null hypothesis, and this is the statement that assumes nothing interesting is happening, such as the Cookie Monster did not steal the cookies. Then we make a mathematical model, a little bubble, that represents the world in which the null hypothesis is true. We describe this world through calculations, but the bottom line is that we assume the Cookie Monster didn't steal your cookies. Now we ask, what is the probability that this world coughs up data as weird or as incriminating to the Cookie Monster as the evidence that I found? In other words, how weird is it to find blue fur in my kitchen or see cookie crumbs on my windowsill? And we call this probability the p-value. Is my evidence so far removed from reality that it makes the world that we have modeled look ridiculous? Now, since the p-value is a probability, it's in between 0 and 1. A small p-value would mean that the evidence we found is very, very weird. Now we compare this value to a threshold called the significance level, which is the cutoff of how much unusualness we will tolerate until we reject this idea completely. So if we find evidence that is so unusual and makes our world look so ridiculous, then the p-value would be smaller than the significance level. And therefore we would reject the null hypothesis, aka reject this world, in favor of the alternative hypothesis. In other words, it is so strange that I found blue hair in my kitchen that I am rejecting the idea that the Cookie Monster did not take my cookies. Again, we don't know for certain that the alternative hypothesis is true, but we have enough evidence to reject the null hypothesis. So when do we use significance tests? Well, over the last few years, we've been bombarded with questions like which COVID vaccine is the best, or is this new cancer treatment effective? All of these questions have been addressed through scientific studies that collect huge amounts of data. In order to interpret the data, it is important for scientists to understand significance tests. Equally important is the ability for everyone to understand the conclusions of scientific studies. That way we can better understand what the world of science is trying to communicate and curb the spread of misinformation.